What's up? What's up, peeps? Hey, my name is Lee. I'm here with Stefan. We're here for Tanzu Tuesday, episode 89. What's up to the chat? To people joining us with YouTube and Twitch. A couple of people streaming in. If you're coming in here, drop where you're coming from. I'm out here in Denver. Where are you dialing in from, Stefan?
I'm from Bucharest, Romania.
Yeah. So from the complete other side of the planet, I don't know. It's like 1 o'clock for me here in Denver. I think it's
9
like
o'clock here. In the evening.
Thanks for coming in and joining with us. We're going to be having a pretty sick session today. And I know there's a couple of things going on in the world right now for sure. Cannot turn a blind eye to the events that are happening in Ukraine. What's that like, kind of having that in your backyard, Stefan?
War is terrible everywhere it happens, but when it happens near you, you are, more scared, more afraid of what's going on. And I really hope this madness will stop as soon as possible. And things will get better, hopefully.
Violence certainly is madness, isn't it? But we're keeping it a little bit light here today. Definitely, there's ways to help regardless of where you are in the world. Go and donate to the humanitarian relief. Go and talk to somebody. Go check on your friends and make sure that people are okay, and make some new ones. But speaking of friends, we do have friends popping in here. I see Kingdon Barrett. He says, "Hello, Flux friends. I am in South Bend, Indiana." Shout out to our viewers joining in from South Bend. We have Sweet Killer 9, a regular Tanzu stream viewer. What's up, Sweet Killer? He says, "Salut, Stefan."
Hey, Sweet Killer.
And then, cool, developer guy. Hey, what's up? I think I first met developer guy in the Falco community, if I'm not mistaken. So he says, hello from Turkey. So we got people all over. Yeah, Christian coming from Munich. Java Grunt says hi. That's Deshaun. He's on my team. He's a pretty cool fellow. Yeah. We got India. Excited for this interesting session. Yeah, it'll be really cool. Thanks for joining in and saying hi. And nice to see another Romanian here. So you're representing the GitOps community very well here, Stefan. Yeah. What's new? So just a full disclosure, I'm so excited about today because Stefan and I used to work together at the Weaveworks team, and on the Flux project, right?
Right.
How long have we known each other? It's been since I don't know. When did we meet?
I think we met at KubeCon in Copenhagen. No.
Yeah.
KubeCon
is coming up again. Yeah.
Are you coming to Valencia?
I should be there, I think. Yeah. We're gonna be doing some so Tanzu Community Edition is kind of one of the projects I try to stay focused on, and we'll probably do some more demo stuff at the booth there. So if you're gonna be at KubeCon EU, I'll be sure to put together some repeatable live demos. We can all play around, and of course, it's a conference-driven development as well. There'll probably be something cool launching. Right?
I have a talk around Flux multi-tenancy and security things at the maintainers track.
Excellent.
And on the last day of the conference, Friday, when it's also my birthday then, I will be like 40 years old. I will be talking about Flagger Istio and all that stuff.
Nice. The big 40.
Yeah.
And we can all go and chill out and do something fun over there. So you're going to be at KubeCon physically then?
Yes.
Okay. Well, you heard it here. If anyone in the chat is heading to KubeCon, we can meet up with Stefan and you can pick his brain there, as long as he's not trying to check out on his birthday. Right?
Everyone is invited Friday. We party.
It's since it's been so long since we checked in with each other. How is dog training going? You have any pictures of your dog?
Oh, dog training. Uh, it's getting harder right now.
Yeah.
She learned some tricks, and now it's more about learning her how to behave better in society and not be too excited when she sees other dogs, because she's like, I have a Shiba Inu, and she's like a girl, and she's very, very excited every time she sees another dog or even a cat or everything. She wants to play with everything. So some other dogs are, hey, what are you doing? Give me some room, give me some space. And she's not that good at giving uh, other dogs space.
That's how I feel sometimes with CNCF projects. Like it just another project comes into the room. I'm like, oh, I want to play with that, right?
Yeah.
People are like, yeah, chill out, man. You don't have to install every service mesh ever. So
Don't mess up my
Pepsi,
alpha release.
some of you have met Pepsi because he went to KubeCon North America. Pepsi is my dog, and he's very much the opposite of Stefan's Shiba, because he's not really like I want to play with you. So it would be funny if they met, because maybe
One day.
you could get Pepsi to play a little bit. Cool. Well, today we're coming in, and you're going to be showing us a little bit of GitOps theory, right? And then getting into a little bit of a demo as well.
Yeah, I have prepared some demo, and hopefully everything will work. I'm going to showcase what Flux can do. How can you wrap up applications, open source projects from whenever they are, and onboard them on your cluster, and then do progressive delivery with a demo app.
And can you tell me a little bit about this idea of progressive delivery? Because I know Flux it's a system for doing GitOps, right? Like you can build a GitOps platform if you're big or you're small. But what is this term? I feel like I've heard about different kinds of delivery, continuous integration and deployment. But what is progressive delivery?
Yeah, so in the continuous delivery system, you change something, right? And that change gets straight on the cluster, and whatever you have changed is exposed to your end users. The idea of progressive delivery is that changes are not shipped to all users at once. You gradually expose users to the new feature. And there are ways of doing that inside your application with SDKs, with all sorts of things, with future flags and all that stuff. And there are ways of doing this like a black box without modifying anything on your app. You use Kubernetes, you use layer 7 networking, like a proxy, an ingress controller, and so on. And you use these infrastructure APIs to route traffic basically from the older version to the newer version. And while you are doing that, you also check for things like, is the new version working or not? Are people running into errors and so on? So progressive delivery is a concept where you break apart the deployment from the release. So let's say Flux, which brings changes from the Git repo to the cluster, does the deployment, but that's not actually a release, right? There is another thing called Flagger, which Flagger takes over from Flux and does this progressive traffic shifting, looks at metrics and so on.
Yeah, Flagger is such a exciting technology. I know you were the initial creator a couple of years ago, and if you haven't heard about Flagger and progressive delivery, I know that we're having some new viewers join as well. Then Stefan is the person to hear it from. He is quite the committer, always building software, always sharing new ideas. Quite an innovative person to be hearing from. So I think all of us are pretty lucky to be hanging out here with him, and I'll give him some space to maybe share his screen a little bit and talk about some cool ideas. Flux, Flagger, GitOps, and progressive delivery is what we're getting into today. So yeah,
Cool.
You might want to minimize the thing, I guess, Stefan.
Yep.
Here you go. Yeah, and then I will pop you up here. So
okay, I'm guessing you can see my screen.
Yeah, you should be good.
Okay. Yeah, so let's talk about Flux a little bit. So Flux is a CNCF project. It started at Weaveworks. We've donated this project some years ago to Linux Foundation and CNCF. And over time, it has evolved from a simple daemon that could watch a single Git repo to something that looks more like a platform where you have all sorts of Kubernetes controllers that you mix together to create a delivery platform, if you want. So we've created Kubernetes controllers that have specialized roles. For example, one of the core Flux components is called source controller. And as the name says, source controller deals with sources. Sources of what? Well, sources of your Kubernetes objects, which are represented as YAML files somewhere. That somewhere can be a Git repository, a public one, a private one, or I don't know, an S3 bucket on AWS, or something like an S3 storage, compatible S3 storage, like a Minio cluster, Azure Blob, and so on. It can also, Flux, the source controller can also reach out to sources which are packaged as Helm charts. So you can, for example, tell source controller, hey, go fetch this Helm repo, look at its index, and from there, you can tell Flux to choose a particular chart version and deploy that on the cluster. And we are expanding source controller to new territories, not only about Git. What we are currently working on is adding OCI support to Flux and source controller. So, for example, you could bundle your manifest into an OCI container image, and you push that to a container registry, and you can use that as the source of truth for your clusters. So that's the source part, which is a core feature of a core component of everything that Flux does. And from there, we have these specialized controllers like customized controller, Helm controller, which know how to reconcile a particular source on your cluster. And they have different features. For example, the Helm controller is capable of installing a Helm release, upgrading it, run Helm tests, do a rollback if a Helm test fails, and so on. While customized controller allows you to layer things with a customized overlays, and it also has this multi-tenancy feature where you tell the controller, hey, when you reconcile a particular source, let's say an app repo, instead of allowing the owners of that repo to place in their whatever they want, you can limit what's in that, can control what's in that Git source through Kubernetes RBAC. And you can say, I don't know, in the app repo, you are not allowed to have cluster role bindings or custom resource definitions. You can only have deployments, and those deployments can go to these particular namespaces. Mm-hmm. And how this multi-tenancy work in Flux, we integrate with Kubernetes, with the Kubernetes impersonation API, where Customized controller basically impersonates a service account that is assigned to a tenant, and all the actions that it does, like applying manifests, look at the deployment status, garbage collection, deleting manifests, deleting deployments that were deleted from Git. All these actions are performed under that service account. Right.
You're already getting loads of interesting questions, Stefan. Actually, interesting one earlier was if Flagger changes should be committed back to the GitOps repo, like whether or not stuff that's reflected in the cluster should be changed, like that there's a loop there. And I think the answer to this is that it's declarative, and so the changes that are getting reflected in the cluster, they're already in the repo, right?
Yes, Flagger comes with a custom resource we'll see later on in the demo called Canary, where you define how Flagger should reach the desired state of a particular revision, right?
Mm-hmm. And then someone's asking for the diagram to be, we'll get more into Flagger canaries later, but it is an awesome question. Thank you, Vincent. And then getting a request just to zoom into the architecture diagram a little. And then Apar Mejiani wants to know, what's the advantage of using OCI over YAML? I think the answer is you use both, right? With source controller.
So OCI is just another type of storage to Flux. Like a Git repo for Flux is a storage where Flux reach out to that storage, which is external to the cluster. It takes the YAMLs from there and it bundles them in a tar file and stores that tar file inside the cluster. So let's say if the GitHub connection drops, that doesn't mean that Flux can no longer reconcile the cluster. It will always reconcile at the latest version that was pulled inside and cached inside the cluster. Now, instead of using Git, you can have like a CI job in your Git repo. And when you commit something, when you change something to the repo, you have this CI job that does like Docker build and Docker push, but it doesn't do a build of an app container. It does a build of a container which has the content of the Git repo, the YAMLs, inside that container image, and you push that to the container registry.
Yeah, so it could even be like a build of some source code that produces YAML, right?
Of course, you can use, I don't know, JavaScript or any kind of language that can generate static files, and if those are valid YAMLs, you can push those to OCI, or which currently works with Flux, to an S3 bucket. So from our perspective, from an operational perspective, there is not a difference between I'm using Git, I'm using S3, a bucket, or I'm using an OCI. These are just storages for YAML. What's important is about the important bit around here is about availability and SLAs and stuff like that. Maybe you want a better SLA than what GitHub offers you, or GitLab offers you, or maybe you want the source of your manifest to be closer to the cluster. So maybe if the cluster is in a particular region, you will create also a bucket in that region. So you don't get, Flux doesn't have to reach out through the internet to take the manifest. It will just go to that thing which is very near the cluster. And the same advantages are with using OCI. But you will still collaborate on a Git repo with your peers when you define your cluster state, when you want to deploy a new app and so on. You'll still be using pull requests when you make changes to your production cluster so others can review it. Like, we cannot take if you take the human factor out of it and we look at these things as pure storage, then yes, there is no difference between them. But the human factor of, maintaining a production system, being on call, dealing with incidents and so on, cannot be done by just, okay, if you and me are on call and something breaks, we are not going to edit files in an S3 bucket or do Docker build, Docker push every time we want to change something. We will probably do it in Git in a collaborative manner with a pull request. We are going to review what things we are going to do. And afterwards, after we merge that, it's a matter of decision. Okay, will Flux get the manifest directly from my Git repo, or from there I'm going to bundle the manifest, maybe push it as a bundle it as a Helm chart, push that to the Helm repository, or bundle it as a container image, push that, or just leave it in Git or S3 or whatever.
And the advantage is like you're as a team, you're creating a technical solution to a social problem, right? Which is how do I version some immutable artifacts, right, that represent my config, and is there like good ways of working around that? For some people, Git it alone is good enough, right? But say you're a vendor of some Kubernetes software, you might want to publish your config to an OCI registry. Well, I guess the team is working on helping Flux consume those kinds of things, right? So
yes.
Yeah, I don't want to let all of these really interesting questions get in your way, but Alexander Smirnov just wanted to know if you've heard of Kayenta from Netflix. I guess it's another traffic shifting progressive.
Oh yeah.
Yeah.
Yeah,
do you have
it's
any comments on that versus
Spinnaker extension or something like that.
Yeah.
Yeah.
So lots of cool things that people are asking about, but maybe getting back to, I think you were talking about policy and how Flux enables policy and multi-tenancy, right?
Yes. So the idea is that with just what Kubernetes gives you, like RBAC and service accounts, and maybe an admission controller like OPA and Kyverno, you can, use these tools to create this tenant concept. Flux that does not come with a tenant concept. It's up to you to define what a tenant is and tell Flux through these concepts, RBAC, service account, policies around OPA or Kyverno, how to limit those, right? The only thing that Flux does is this bit where it does impersonation, and afterwards is up to you to decide how you can orchestrate all of that. We have, for example, the Flux is composed out of these controllers, but it also comes with a CLI, and the CLI is for debugging Flux, generating YAML, so you don't have to type it, and also it generates for you the tenant object. There is a Flux create tenant command which generates namespaces, role bindings for those namespaces, service accounts, and so on. It's more about to give you an idea of how you can define your tenant, but it doesn't come with a very strict thing, and it's up to you to, match the tenancy idea with how your organization is constructed. Maybe a tenant is a team. Maybe a tenant is an app that belongs to a team. Maybe a tenant is a client if you are some vendor and, I don't know, you self-host, you offer Kubernetes as a service to them. There is a lot of talk about platform teams, right, where they service Kubernetes for all the other parts of the organization and so on. So
yeah, what I'm hearing is that Flux like provides you very granular primitives, right? And you can decide whatever way your organization works, you can encode that into your platform, right? Christian had a question about kind of your comments on tenancy, and he just wants to know, he says, so multi-tenancy is achieved by impersonating some service account. What's the difference to using Kyverno policies, for example? And I think you probably have the most nuanced answer on this, right? It's like a combination.
Well, Kyverno can block things, while Flux reconciles applications, deploys applications under a particular service account. So there is one way with policies, with Kyverno, with OPA, with whatever, to block things that are not supposed to be there, which is fine, but they don't actually do the deployment bit, right? So that's what Flux does. Of course, when Flux deploys something, let's say applies a Kubernetes service, a Kubernetes deployment, an horizontal pod autoscaler, the first thing it does before it applies it, it does server-side apply dry run. And what that means is that it goes to the Kubernetes API and says, hey, what will happen if I am going to apply all these resources from this repo? And Kubernetes will respond to that by calling all the webhooks, all the admission webhooks, validation and mutation, and it will give back to Flux the result as it will be stored in etcd. And
so that's where your Caverno policies can fire, and then the errors will show up in the reconciling resources in Flux, right?
Yes.
And you could even write Caverno policies that are sensitive to which Flux service account is being used, right?
Of course.
Like based off of the user fields. So that's a great question, Christian. Thanks for asking it. And,
yes, there is. So we have a repo. 1 second, I will show it here super fast. So we have this Flux multi-tenancy repository where there is a lot of talk here around roles, platform admins. They have cluster admin tenants, they are restricted and so on. And down here, onboarding tenants and so on. And here, we actually have Kyverno integrated in this repository to showcase how admission controllers can be additive to Flux multi-tenancy. For example, here you define a cluster policy for verifying the Flux images themselves, that they are signed with cosign and so on. Then you can apply cluster policies to Kyverno to Flux custom resources. And one example is, hey, for a particular tenant, this tenant can only use sources from GitHub under this organization. Or this tenant can use sources from GitHub under this organization and only use HTTPS and GitHub tokens to acquire the sources and so on. So instead of building a policy agent into Flux, we felt like the solutions which are in CNCF, both Kyverno and OPA Gatekeeper, are strong enough, are really well built. So you can not only apply policy to the things that Flux applies, but you can also apply policy to the Flux objects, those that define your continuous delivery pipeline, right? And enforce all sorts of things. Okay, let's start the demo because it's going to take some time, and let's get it started, okay? Okay, so I have a cluster here. It's a Nikes cluster. And so I am now playing the role of, if we talk about multi-tenancy and so on, I am playing the role of the platform admin. I have created a cluster somehow. Let's say I have created with EKS Cattle the CLI, but you can do it with Terraform and in many, many ways. You have a cluster, and now how do you onboard a particular repo on that cluster with Flux? So we don't have Flux installed or anything. We have installed the Flux CLI locally on this machine. And the command that allows you to install Flux and match Flux with the Git repo is called Bootstrap. So Bootstrap has a lot of flavors. You can bootstrap against GitHub, GitLab, or you can Bitbucket, or you can use plain Git if you have SSH agent, or you can give the Flux CLI a private SSH key. So you can use it with any kind of Git provider. But for convenience, Flux Bootstrap GitHub does a lot of things. For example, here I'm telling, hey, create this repository called PD demo. under the user, under my user, make the repo private, it's personal, this is the default branch. Besides all the default Flux controllers, install these extra controllers, which are about image automation and reflection. We'll talk about that later on. And what the Flux Bootstrap command does is talks to the GitHub API. It creates the repo if it's not there. It can set up team access to it and so on. And it also generates, using your personal token, an SSH key. It stores the private key on your cluster, and then it talks to the GitHub API and stores the public key as a deploy key on your repo. So even if the CLI requires a token which has admin access to this GitHub organization or to my GitHub personal account, that token does not leave my local machine. Flux on the cluster will not use that token. You can tell it to use it if you want, but by default, what Flux Bootstrap does, it creates this unique SSH keys for each cluster and each repo that it's being bootstrapped. So, okay, let's run this command and see what happens. So it has reached out to GitHub. It found the repo I created earlier today. It has made a clone locally on my machine, and it has generated all the Flux manifests, custom resource definitions, deployments, cluster role bindings, RBAC, and so on. And it has pushed all these manifests on the repo. Why? Because Flux is able from this moment on to manage itself. So in order to upgrade Flux, you don't have to run the Bootstrap command again, even if you could. What you can do is modify the Flux deployment in Git, and Flux will upgrade itself. And we also have a GitHub action that people can use to fully automate that. The GitHub action looks at the Flux 2 repo. When we do a new release, it will open a pull request on your repo with all the Flux new version. And when you merge it, Flux upgrade itself. So that's what it did here. Install the component, reconcile the component, and lastly, it has generated the secret on your cluster, and that secret contains the private SSH key, and here is the public one, and this one is already set up in GitHub. Let's look at what happened on GitHub. So here is the repo, PD demo. Let's refresh this. Okay, so it has created this file structure, clusters, my cluster, because that's how I name it. Of course, here, instead of my cluster, you should give actual names to your cluster, like staging, production, maybe mention the zone, the region, and so on. And in here, it has created a directory called Flux system, the same as the namespace has created, and it has committed here 3 files: the components, the sync manifest, and a customized configuration. If here you want to further modify Flux, I don't know, maybe you want to bump the CPU limits, or maybe you want to assign the Flux controller a particular IAM role, or give it a workload identity in Google Cloud, and so on, right? You can do all sorts of customizations here. And if Flux finds this file on the repo, when it does the bootstrap, it will take all your customizations into account. So you, at install time, you can customize Flux in any way possible. You can here, patch all the things at install time. And if we look into the settings of this repo under deploy keys, we see that the Flux, the CLI, has created a deploy key that the name of it is unique to the cluster. Why? Because you can use the same repo to bootstrap not one cluster, but your whole fleet of clusters, and then set different paths for each one: staging, production 1, 2, whatever. And here is the public key that allows Flux from my EKS cluster to connect to this repo. So this is what the Bootstrap does. It's a single command that allows you to automate all stuff. It's also, you can run this command no matter how many times. It will not change anything if there is no diff between your the version of Flux bundled with the CLI and what's running on your cluster. So now, if we look at the cluster, we can, of course, look at the Flux system namespace, see get pods, and we see here all the controllers that have been installed. This is what I've shown before. There are also Flux CLI commands like Flux check, which verifies the version of your Kubernetes if it's compatible with Flux and so on. And then it does a health check of all the controllers and it shows you each version of the controller. So let me explain a little bit about versioning, because this is also something that you could find odd. So Flux, the CLI, has a version, and then each controller, each component has its own versioning scheme. What that means is that Flux, the CLI, when we publish a new version, we test all these controller versions together. We have conformance tests, end-to-end tests on ARM64, on AMD 64. We run a whole suite of end-to-end tests to make sure that all these versions work well together. And then we generate this manifest that contains all the deployments, custom resource definitions, and so on. And we bundle them into the Flux CLI binary. So you don't have, the CLI does not go to GitHub to download all the manifests. They are inside the CLI. And why we did that, because you can also deploy Flux on behind the firewall on systems that have no access to internet. So we at the Bootstrap, you can specify a different container registry, and if you mirror all these controllers, all these controller images on your private repo, private container repo, Flux the CLI will use those. So that's what Bootstrap does, and how the Flux CLI helps you, with a single command, automate the whole thing. Now, for some of you, this may not look appealing, right? Maybe you create thousands of clusters, you use Terraform or whatever to generate those clusters. So besides the CLI, we also offer a Flux Terraform provider that does the whole thing. It uses the same Go code as the CLI inside the provider, and it basically does the whole Bootstrap stuff from Terraform. And the Flux community is also maintaining Helm charts for all the Flux components, and those Helm charts, you could use them again in Terraform or any other tool to mimic what the Flux Bootstrap CLI does. Any questions?
I think Jerome actually had a very kind of a larger question, and he said that'd be totally cool to answer it earlier. I'll put it up on the screen here. This is Jerome Pettazzoni, Docker legend, coming in to ask a question.
Hey, Jerome. Yeah.
And he says, "Hi, Lee and Stefan. First of all, happy to report I just secured my KubeCon ticket, so here's to hanging out in Valencia." Then the GitOps question. If I want my workflow to involve some sort of validation, like if I want to go to prod with pushing to a specific tag format, or if I want to add a specific message that shows up in GitHub or GitLab, like /deploy or even some Slack message, then what is or isn't supported in Flux?
So Flux has this command which is called reconcile. We'll use it a lot. So what this command does, it annotates the Flux custom resources that triggers basically an on-demand sync. Flux by default pulls your latest version and so on from a branch or from a Git tag, and with this reconcile command, you can tell it to do it instantly. Now, what exactly will be reconciled, you can define in the Flux custom resources, and we'll get into that, where you can say, for example, to Flux, hey, get the latest Semver release of a Git repo. So if you do Semver releases using Git tag, you can tell Flux, hey, only deploy on the production cluster a stable release, and on the staging cluster deploy pre-releases, and on the development cluster deploy every single commit to a particular branch. So
right.
how do you
That's
control?
that's like the release policy, and you can do that in the source object, right?
Yes, when
So
you
like
define a Git repository. Let's see how Flux deploys itself from here. So I'll try to use code spaces. Oh, okay. Maybe later. Yeah. Okay, so there is this sync YAML, which contains two Flux custom resources, which were generated by the CLI. So that's why do not edit. This thing is generated by the CLI or the GitHub action if you use that to keep Flux up to date. So these are the constructs with how you tell Flux to take something from a repo, and that something is a Git repository custom resource that has inside the spec an interval, at which interval to check for new commits. And here you have a ref where you have the branch. So this configuration, and of course, a secret which was generated with the SSH keys and so on, and a URL where is that repo. So what basically happens here, you tell Flux, hey, follow the main branch. But instead of branch here, you can use tag, or you can do semver and so on, and tell Flux exactly what things it should pull from Git. Now, this custom resource doesn't change your cluster state in any way. When you create a Git repository on the cluster, and if we look at one, Flux get sources Git, we should have one, which is called Flux system, right? Tells me, hey, I fetched this revision main at this Git shop. Now, if I want to apply something from the repo on the cluster, I have to create either a Helm release or a customization, and the Flux customization custom resource is something that allows you to set a path. I want to apply a particular directory, and in here, in this directory, it can be a customized overlay, or it can be plain YAMLs. Flux knows how to generate customized overlay from any kind of structure. You don't have to use customized overlay if you are not into that. And here you configure Flux, hey, apply all the things in this directory. With prune, you enable garbage collection. So the moment you delete something from there, Flux will delete it from the cluster. And the customization has this source ref, right? Where is that directory? It's in this source, in this Git repository called Flux system, which is this one, right? So this is very different from what Argo and others are doing when there is a single custom resource where you define everything. In Flux, we have this structure where each controller has a specific role, like source is the source controller and only deals with sources. It can do Git repositories, buckets, Helm repositories, and so on. Then you have to create the second object that references a source. And here you can configure a bunch of things, like you can change the image, container images. You can patch the things that are in that path with customized patch or strategic merge patch, JSON patches, and so on. You can override the namespaces of all your manifests and stuff like that. Right, so it's more about the composition of custom resources, a composition of APIs where you can build this delivery pipeline.
So using these objects, you can then kind of take the declarations of where you collaborate on manifests, right? Like if it's in Git or other sources like buckets and that kind of thing, we're adding OCI sources later. Then you can like sort of filter on a reference and then have source controller kind of pulling in the most common things, but then you can also stop the reconciliation separately, right? Like if you want to put that through a gate system or that kind of thing, you can.
Yes.
Or like say you have a break fix thing, you can go and stop the customization, you can go change things, and like Flux isn't going to step on your toes because you've paused that part of the reconciliation, right?
Yes, there is a Flux suspend and a Flux command, a Flux suspend and Flux resume command that targets the cluster directly, or you can suspend and resume things directly from the cluster by adding here inside the spec, suspend it true or false.
Yeah.
I want to get back a little bit at modifying things directly on the cluster. We recently made a change in Flux. So last year and since the beginning of Flux, Flux would use kubectl and the kubectl logic, the three-way merge, to apply things on the cluster. What this means is that Flux wouldn't be able to undo things that were changes that were made with kubectl if those changes don't overlap with something in Git. So let's say if I would do a kubectl apply of this object and I'm going to modify here the URL, Flux version 1, Argo, whatever, will be able to undo the URL modification. But if I'm going to add a new thing here to the spec, like suspend true, because of the three-way merge, when you do a kubectl apply of something and then you apply an object which has missing fields from the first apply, what the kubectl logic is, it will merge all the fields inside the cluster. So basically, if someone sidesteps GitOps and starts to add init containers to your deployment, for example, and those init containers can do really messy stuff, or it adds environment variables and all these things, normal GitOps tooling is not able to remove those changes because those things are not specified in it. Now, since a couple of months ago, we have gave up on using kubectl and a three-way merge, and we have adopted a server-side apply, and we wrote our own library for doing that. And now we are able to roll back any kind of change you are doing outside of GitOps. So if you add fields, if you modify fields, if you add objects, no matter what the change is, Flux will determine that the change is not authorized and will undo that change. So if you add an init container with kubectl, Flux will undo it. But if you add an init container, let's say with the linkerd admission controller, because that's running inside the cluster, and it's a mutation that happens at apply time, Flux will allow that mutation to happen, right? Or if an horizontal pod autoscaler goes and sets up a number of replicas, let's say you don't have replicas in your Git repo, the horizontal pod autoscaler sets a replica count. Flux will not delete replicas because, well, it's not in Git. It will allow other controllers to modify things, but external changes made with kubectl are completely rolled back. And I'm very happy we got at this point. It was like the GitOps struggle, if you want, because other people said, great, I'm defining things here, but only the fields that are specified in Git are undo overwritten. What about other things? What if someone by mistake does a kubectl edit or whatever? It's in a debug session, let's say, right? You have an incident, you add some init container, and then you resume Flux. That init container will be there forever, and it could cause a lot of things, I don't know, security issues and so on.
It's so funny that you mentioned this, because I think it sounds really complicated, right? The problem that you're trying to express, like it requires so many words. It sounds like such a niche edge case, but it's not. Like any cluster administrator who has dealt with trying to figure out how to stay organized and be confident that what they want in the cluster is actually in the cluster has this issue, because the problem of dealing with merge patches and the different applier fields, and then finally like the more modern solutions with server-side apply, these are really hard problems to build operator type software around. And what you're expressing here is that you found like a very good way to deal with the default bad behavior of a GitOps operator fighting with somebody expressing their unauthorized will on the cluster, right? So you've almost invented the most granular policy controller possible, which is that this is exactly the object I want in the cluster, and Flux knows how to make that happen, obeying the mutation webhooks and preventing people from making unauthorized, untrackable additions with kubectl, right?
Yes, I mean, we wanted to do that since many years ago, but
Exactly,
it
but
wasn't
it was so
possible.
hard.
Kubernetes wasn't there.
Yeah.
Like kubectl was this fat client with tons of logic inside. The three-way merge is pure client side, right? So you had to stick with that. Then Kubernetes has evolved, and now the Kubernetes API has this server-side apply feature where you no longer rely on client-side logic to do the merge and to decide which fields belong to which controller, which owner, and so on. With kubectl, for example, every time you apply something, it creates an annotation of that object and duplicates the whole object in the JSON format in that annotation called last applied configuration, right? Which has a lot of issues. For example, you cannot apply an object that has 4 megabytes, a Grafana dashboard, config map with a Grafana dashboard, because the annotation will take almost the same size, right? And so on.
Yeah,
Now with
little weird
server-side
API
apply,
machinery limitations that come from the engineering around the Kubernetes API.
yes.
Basically, if you're listening and that sounds scary to you, you know that you can just rely on using Flux instead of writing your own shell scripts in CI, because the projects is well engineered against these kinds of edge cases and will give you nice warnings and stuff. I want to highlight just a few things happening in chat here, and then maybe we'll talk about one more thing and you can get back to your demo.
Yes.
One thing is Scott Rosenberg, awesome contributor from the kind of Carvel Tanzu ecosystem. Just wanted to know if there was a way to use like YTT kind of as a plugin at runtime. And then Kingdon just hopped in here and said that Flux doesn't shell out to arbitrary tools at this time. Not that you couldn't put something in the middle of Flux components and build your own thing, but there's just not like any example of this being done. But that there are recommendations and there's guides like on the Flux docs for how to do this before resources ever get to your cluster with CI. And this is also another case where that OCI image being published, maybe using like image package in CI would be nice. So there's ways to do that where you can use YTT and JSONet and all of these other tools along with Flux reconciling your resources. Christian had an on-topic question about getting stuff into the cluster as well, about validation. He wants to know that if you're using SOPs and then they're validating manifests, right? Then you have these SOPs encrypted Kubernetes YAMLs with this extra SOPs field. And this cannot be validated against any CRDs that exist in the cluster. Do you have a suggestion for how to fix this?
Yeah, don't use SOPs for anything else than secrets. You shouldn't place secrets in custom resources. Even if it's SOPs encrypted, it's not encrypted in etcd. Use Kubernetes secrets and mount them inside containers. That's the way to be secure. I would not encrypt anything else but a Kubernetes secret. So, for example, the Flux diff command, which gives you an overview of local changes against the cluster, what we do in the Flux diff command, we basically strip the SOPs fields, and we only compare the keys, not the values. So we never decrypt stuff locally. right? Even if we could fetch the key from the cluster and so on, but we felt like this is highly insecure. But yeah, my suggestion is do not encrypt deployments, I mean, environment variables and so on. Use what Kubernetes offers, the Kubernetes secret, which on some platforms that only secrets are encrypted in etcd, and use those to mount them in environment variables, files on disk. That is the best way, maybe RAM disk and so on. So yeah, that's
some other things I can think of might be to just pipe through GoJQ or YQ or some YAML slicing tool, YTT. You could use YTT and drop fields before you validate them. Or if you're in a very secure environment with secure logs and secure compute to do this operation in CI, you could potentially decrypt the things before validating them. But you would have to be very careful that those log messages don't output secrets. So that's why Stefan's recommendation for only using systems that pull values from reference secrets, and so that your fields don't get polluted too much in the things you're validating, is a good suggestion. So great question, Christian. Thanks for coming in and asking such good stuff. Stefan, I guess just
one second. Let me get back to the first question. Why we cannot run YTT or JSONnet or some random bash script in the Flux pipeline? We had this feature in Flux version 1 where you could just add binaries to the container like Argo does and others. And then there was a mechanism where you could tell Flux, hey, before you apply YAMLs, run these things for me. Those will generate the YAMLs and then apply them. And that proved to be like a security nightmare. Like, there are 1 million ways on how you can, be completely taken over by a tenant which has maybe not good intentions, or maybe the tenant I don't know, keys or whatever were stolen. So in Flux version 2 we made a conscious move where we said we no longer shell exec to anything. We don't support any external binary, not even Git. So we also dropped the Git CLI. We don't use Git. We use libgit2, which is a C library under Linux Foundation, and we use GoGit, which is a native Go library developed by the Go community. And there was a huge struggle to make these two libraries work well and be able to do what you can simply do with a Git clone and Git pull and Git push. But I think it was time well spent because we had a security audit, and the results were very positive. You can not actually take over the whole thing by just placing scripts, binaries, or whatever, because Flux will never shell out, will never exec to anything. So if you are using some kind of CLI, some kind of language that generates YAMLs, the best way to do it is in CI, push those YAMLs to a branch where Flux reconciles that branch, or push those YAMLs, I don't know, bundle them as a Helm chart, or push them to an S3 bucket, soon an OCI, and so on. But I don't see a future for Flux where we'll just say, yeah, we'll let you run whatever. Continuous delivery is not continuous integration, right? In continuous integration, you are used to run scripts, all things. But those should be all the things that you run in CI. CI should not be able to connect to your production system, should not be able to do a kubectl, get secrets, all namespaces, and so on. So if you isolate your CI, it's perfectly fine to exec to a bunch of things, or let tenants add new scripts there and so on. But when you do that inside the cluster, there are like really bad side effects. So
like if you're running a CI system inside the cluster, like the infrastructure team is going to want to segment that onto particular compute nodes, maybe even use a different control plane completely, right? Like you don't want that stuff intermingling and having potential provenance to have arbitrary executables in supply chain attacks directly talking to your infrastructure, right? not that it's not possible to, you know, put a binary and be careful and like mutate the way that stuff's applied to the cluster at apply time, but just that it's a very security sensitive attack surface, right? And the Flux security posture is a very stringent one that is acceptable for the most high compliance environments.
Yeah, in a way like Kubernetes. So Kubernetes, the Kubernetes API is one instance for all the namespaces for all your tenants. In the same way, Flux and all its controllers, they are all shared by the tenants that are sharing the cluster. So in order to isolate those tenants, our code has to have no escapes. A tenant cannot control how the code runs inside our controllers, because if you gave them an escape hatch, like a customized plugin, there are like tons of people that said to me, hey, you build customized controller and you don't allow plugins and so on. Like, no, because then a tenant will be able to run a plugin inside the controller, inside the container of a controller that has a cluster role binding to cluster admin, right? There is no Kubernetes impersonation that can, protect you from that, because if you have access to the file system, right, you can just go and fetch the token of that service account, which has cluster admin, and you can do whatever you want, right? So due to these considerations, we kind of took away some of the Flux v1 power, where you could do whatever you want, run JSON at YTT or whatever, any basket. We took away that, and we told people, hey, if you are generating YAML, do that in your CI pipeline and push that YAML somewhere where Flux has access to it. That's the current approach, and I don't think it will change.
There's certainly space here to build a config build controller that sits in between source controller and customized controller, you know, in the future, that kind of thing. And that would allow you to do these sorts of CI build steps at runtime in between, you know, and you could run validation steps and that sort of thing and really lock it down to a particular security policy. Yeah, it
still needs a pod per tenant, and that pod should run in the tenant namespace.
Exactly.
Running that in the Flux system namespace, where you have all these service accounts which are really powerful, because Flux has to reconcile custom resource definitions, namespaces itself, cluster roles, and so on. I don't feel good about running stuff that we are not audited, is not the code that we wrote, run some other people's code in there. Is not how I envision Flux moving forward. Yeah. Okay, let's get back to demo, because
one more thing, Stefan. Yeah. Could you talk a little bit about just to go back to Jerome's question, right? Which is that he was wondering about not just about getting stuff into the cluster and filtering on tags, but what about messaging in Slack or posting a status to GitHub and that kind of stuff? What does Flux support there?
Yes, we have a component called notification controller, which we have this controller which has two roles. One is to listen to events from outside the cluster, like GitHub webhook, GitLab webhook, a push to a container registry, and so on. And based on those events, you have a custom resource where you say, hey, listen to events from GitHub, and when there is a new commit, tell source control, hey, go and fetch the commit, don't wait 10 minutes for it to happen. So that's one side of what notification controller does. And the other side is listen to events that happen inside the cluster, events that are emitted by the Flux controller, source controller, customized helm, and push those events to various sources. And we support a bunch of things here. Let's look at the alert providers. And we can push events to Alert Manager, Azure Event Hub, Discord, Google Chat, Grafana, the Grafana annotation API, where every time Flux does a reconcile or a health check, it will it will add to your graphs a marker, Matrix, Microsoft Teams, and this one keeps expanding. Slack, of course, Telegram, and so on. Most of these are not contributed by the Flux team. They are outside contributors. They really, okay, I'm using Telegram. I want, every time something fails on the cluster, I want a message on Telegram, and they implemented that and so on. And we can also push events back to Git using the commit status API. So, for example, you commit something to a branch, that change breaks on the cluster. Let's say the Flux health check fails, the deployment that you change is not cannot roll out. Will write on that commit, you'll see a red mark like CI does, and will tell you there, hey, this particular thing failed, and so on. So yes, notification controller is the thing that deals with listening to events from outside and tell Flux to react to those, listen from events from Flux itself, and reach out to end users or other automations. There are people that, for example, have built their own receivers for notifications, and they listen, for example, for customization success apply, and then they run their end-to-end tests and all of that. So. And this is all based on Kubernetes events. Underneath everything is Kubernetes events. We just add some annotations to those, and we use them to drive all this eventing system. Demo time?
I like demos.
Okay, we didn't do much. So we just bootstrapped Flux. Let me pull here the latest version. Okay. So we have the clusters directory, and in here, Flux has pushed all these files. Now, inside my cluster here, I can now create, add Flux customizations and Git repositories and all this stuff to onboard other Kubernetes infrastructure items. And I have created here some things that are needed for Flagger. And I have created an infra directory, which has two directories inside. One is a controllers directory, and one is a config of those controllers. So let's say we want to install some custom resource definitions from a different repo than this one. So there are two options, right? You can, if you want to install a controller made by someone else, you can vendor everything. You can copy all the custom resource definitions, deployments, service accounts, and so on to your repo. Or you can onboard that repo inside your cluster if you trust it. And this is what we are doing here, because all these three projects are CNCF projects, and those repos could be trusted. You trust those repos to generate container images that you run on your cluster. You should trust them for deployments as well. And let's see here, I want to install, for example, the new API, the gateway API in Kubernetes that is a replacement for the current ingress API. And let's see how we can do that. So I'm creating here a Git repository that points to Kubernetes SIG, gateway API repo. I'm using a tag here. I don't want to get the main branch where things can go wrong. I want to use the latest stable release, so I'm referencing here a tag, right? So I'm telling Flux, hey, clone this repo inside the cluster and cache it for me. Then I have this customization object, which uses the gateway API Git repository and applies only the CRDs from this repo. right? So if I want to install some custom resource definition from upstream, I can use this kind of structure to apply them. Another example here is Contour. So Contour implements the gateway API, but you need the custom resource definitions from upstream, and then here instead of a tag, I'm using a branch. Contour publishes branches for their minor releases. And with this one, what I'm telling Flux is get all the patch versions of 120. So if Contour fixes a bug or something, Flux will automatically upgrade Contour on my cluster every time there is a new patch release to the 120 release branch. And in here, I have a customization for this particular source. I'm applying examples render, which is a path inside the Contour repo where the final YAMLs are. But I want to modify whatever is in here to enable the gateway API. Since it's an alpha release, it's not enabled by default. So I have to fiddle with Contour configuration, which sits in a config map, and I have to enable the gateway API. And here is an example of how you can change stuff from upstream using patches. This is like in customize. So this actually, the customize controller uses customize to patch things. And you can define here an array of patches where you specify a stub of a Kubernetes object with the things that you want to change inside that object. And here you specify the target. So what I'm telling Flux here is, hey, after you build this directory and you get the final YAML, before you apply the YAML on the cluster, find the config map name Contour and add this field to the Contour YAML data. All right, so this is an example of how you can customize things from upstream. And the final bit of infrastructure is the Flagger controller and custom resource definitions. And here, yet again, I'm registering Flagger from upstream. I'm referencing the main branch because it's me who does the Flagger deployments, and they're all always stable. Okay, so I'm applying an overlay, a customized overlay from the Flagger repo where Flagger is configured for Gateway API. And yeah, I'm telling Flux, hey, wait for Flagger to start, to be healthy before you move on to applying other things. All right, so I have this directory here. How can I apply it? I can put in here under my cluster another customization that applies all these things from this repo. And I have here two customizations. One that applies the controllers, which are all of these, right? Infra controllers. And another one, which is called infra configuration, that applies the configs. And let's look at the configs a little. Here I am creating a gateway class for Contour. I'm creating metrics for Flagger to look at Envoy, Prometheus, and so on. I'm configuring Slack for Flux to notify me on Slack of what's happening and so on. Now, I cannot apply these things and these things together. Why? Because in here, I have custom resource definitions, and in here I have custom resources. So you cannot apply a custom resource on Kubernetes if Kubernetes doesn't know about the definition of it. How can you define the order, the apply order with Flux? We have a thing called depends on. So in here, when I'm applying the custom resources, I'm telling, hey, this customization depends on infra controllers, which is this one. So this this customization will wait for this one to apply first. All the controllers and Flux will wait for all the controllers deployment to roll out, all the admission controllers to be registered. Everything has to be ready, and all the pods should be running. All the services, for example, if you have a load balancer, should get the public IP and so on. And only after all these things are healthy and running, only then Flux will go forward and deploy the configuration that's using the definitions from this one. Make sense? Hope it does. Okay, let's apply the infra YAML move. Okay, so I put it here under cluster my cluster. And because in here, when I did Bootstrap, I told Flux, hey, apply everything in my cluster. It will also apply this configuration, right? And this configuration applies other things inside the repo. And those other things are pointers to other definitions which are in other repos and so on. So you can see how all these things, how you can map relationships between repos that you don't control, like contour, flagger, and so on, patch them in some way, define an order of which these things are applied on your cluster, and then tell Flux to look over them and do a health check of them and so on. So let's commit this change, and we'll see what happened. Add infra. Okay. Now I will not wait for Flux to figure out there is a new commit. It will check every minute. I can tell it to reconcile right now. So I can say Flux reconcile Flux system customization with source.
This is also a place where a webhook would probably fire in a production setup, right?
Yeah, I haven't set a webhook. You could definitely tell GitHub to tell Flux to do it.
You can do push and polling at the same time. Yeah.
Yes. Okay, so now if I'm doing Flux get customizations, I see a bunch of stuff, right? It has reconciled and apply my controllers, and those controllers have gateways, flagger, contour, also the configs and so on. Now, what if I want to actually see what's in here, right? There is a command called flux tree. So we can say flux tree customization flux system, and I want to print the tree in contact mode. So here I have a different view of what's happening. I tell Flux, hey, tell me what Flux system does. So Flux system applies infra config and infra controllers. Infra controllers contains all these things: Git repositories, customizations, alerts, providers, and so on. If I run this without contact, let's look at contour, for example. If I want to see what the contour configuration has brought on my cluster, I can run it without compact mode, and it basically gives it prints here the inventory of this customization. So Flux, before it applies stuff, it creates an inventory, so it knows how to garbage collect stuff and so on, but it's also useful for inspection and so on. So I see that contour has all these things are basically applied from the contour Git repo. And if I do again Flux get customizations, right, I see here all the revisions for each thing and what they are applied. I can also do Flux get sources Git, and I can see here all the repos that are onboarded on my cluster. The Flux system is the one that I'm controlling now, and all these things are external. They come from other repos outside of my control. Right, so now I have my infrastructure set up. I have my ingress controller. I have my custom resources that are telling Contour, hey, expose any app on the cluster through the gateway and so on. Now let's deploy an app. So if I'm going back here, I have this, let's minimize this stuff. I have this apps directory where I have some plain YAMLs. This is not a customized overlay. I'm just having a bunch of YAMLs in here. So then I have a namespace telling Flux, hey, create this app namespace for me. Then install this application, reconcile this application from yet another repo. So you can see here how this Git repo could point to an app repo maintained by someone from a dev team or someone from your organization. So here I'm creating a Git repository for Podinfo, which is a demo app that sits here at this repo, and here I'm saying install the 6.0.0 version on the cluster and apply here. It's a customized overlay in there. So it has a deployment, an horizontal pod autoscaler, and so on. I'm also deploying here a load test, which is a component that helps Flagger generates traffic so Flagger can do progressive delivery, because we don't have any kind of live users on Podifo right now. And here is an example. If you don't use Flagger, you just use Contour and Gateway API or Istio or any other implementation that supports the Gateway API. This is how I can expose my app outside the cluster, and I'm going to use the ALB hostname here. Of course, you can map here your own DNS names, TLS certs, and so on. So if I want to deploy my app on the cluster, what I can do here, I can create yet another customization which applies everything in the apps directory. I'm going to pull this one here. Right, so next to infra, I have apps. I'm going to commit this change, add podinfo, and sync. And now here, I'm going to reconcile Flux system again with source, so it pulls the latest changes. And now if I do Flux box 3 customization apps, I can see what was applied. So
Fascinating.
right,
That's
you see
so
the
good.
name. Yeah. Okay, so this namespace here is in my admin repo, right? And this stuff here, the service, deployment, horizontal pod autoscaler, I didn't vendor them. They come from the podinfo repo. So if I go here at podinfo, there is a directory that I deploy called customize, which has all these things here: deployment, horizontal pod autoscaler, service, and so on. Right. Now let's see if my app is exposed. Is exposed inside the cluster. So I'm going to go here and see if it works. Going to navigate to this hostname, and podinfo should respond on this URL. Okay. Woohoo! So yeah, I have deployed podinfo from a totally different repo than the one where I've set up podinfo continuous, the continuous delivery pipeline, right? Now, if I go back here at podinfo, And here I'm going to change the version. What Flux will do is say, oh, I have a new ref tag. Let me pull that particular tag, and it will notify customized controller to apply the new changes, and customized controller will roll out 601. What if I don't want to do that and I want to slowly roll out the new version, and I want to expose the 601 version only to some users, test what's happening with them, and only then roll out completely? So what I can do is, instead of this HTTP route that I've set up, I'm going to delete this one. I'm going to move it back because it's no longer here in the directory. Let's actually commit that and see how garbage collection works. Now Flux reconcile customizations apps with sources. Okay, it has applied this version, and now this should no longer work. Right? Why? Because you remove something from your Git repo. You have enabled garbage collection in Flux because there is a prune true set there. So Flux said, okay, it's removed from Git, so I have to delete it from the cluster. Right. Now, sorry. How can I set up a Canary release for this one? I have here a Canary custom resource that I will place in apps that replaces the route. And here is how Canary policy looks like. You tell Flagger, hey, this is the deployment you should monitor, called podinfo, the one that Flux applies. This is the autoscaler you should take into account. So when the autoscaler adds pods or remove pods, Flagger will pause whatever he's doing, let the autoscaler do his job, and only then continue with whatever Flagger is doing. So this is more about playing nice with other controllers, and also creating this copy of the horizontal pod autoscaler and the deployment. And those will be running, those will be exposed outside the cluster. And I'm setting here the hosts, which are the same as the one in the route, and I'm telling which gateway to use. Contour from the namespace project contour. And here is the interesting part. Here is how I define Canary analysis with Flagger. I'm setting up an interval, a threshold, how many times it can fail before it should roll back completely, how to increase the traffic weight from one version to another in steps, and which metrics it should take into account every time it goes from one step to another. And here there are two built-in metrics that any kind of ingress controller or service mesh will expose. It's error rate, an error rate percentage from all the requests that my new version receives was the percentage of 500 errors. And here I'm setting a threshold, and I'm saying if it goes over 1%, if more than 1% of all the requests are failing, this version is no good. And I'm also setting a service level objective for latency, and I'm saying, hey, if the new version response is it can respond in maximum of 500 milliseconds. If the average response time is over 500 milliseconds, then my application is too slow, and I don't want to deploy that to all the users, roll it back, and stick on the old version. This is the analysis based on metrics, and here you can have custom metrics. You don't have to use Prometheus. You can use TechDriver, New Relic. There are a bunch of integrations in Flagger if you use a different type of monitoring system. So So this is the metrics part. And finally are the webhooks. So what's in here with the webhooks is Flagger calls out to a different service to run things like smoke tests or Helm tests or any other thing that you want to run before real traffic, live traffic gets to your application. And this type of webhook is called pre-rollout. And another type of webhook during rollout is here. It's a load test, and that generates traffic for my app. So Flagger has data to monitor.
So I want to zoom out here just for a second so I make sure I'm following, Stefan, because like you've built on many, many layers here. So with Bootstrap Flux, you install the CRDs, you installed Contour and Flagger. You configured both of those things for the Gateway API, which is a new API in Kubernetes routing. And then you configured both of those things with the Gateway class for Contour and like the metrics. And then you deployed your app and then you undeployed it. And now you're getting the app set up so that it's going to be following this Canary description, right?
Yes.
And Flux does all of that in the right order because of the way you structured your repo and like all the customizations are referencing each other with the proper dependencies too. So you're going to deploy your app and then you got this Canary resource. You got Contour and Flagger ready to go. And it's going to like see that you have a new version of your app. And then it's going to be like, oh, let me make sure that it comes up safe with like a complete copy of all my resources that are managed by Flagger. And then it's going to like clone the horizontal pod autoscaler and like make these things like traffic shift between them. And it's going to configure the service mesh and it's going to watch your custom metrics and it's going to do a load test at the same time. And none of this requires any kinds of, oh yeah, the Puppet t-shirt coming from the chat. None of this requires any scripting or like CI job or weird resource.
Just a ton of YAML.
You just put this Canary YAML in here and you just update your app in Git and then it just goes.
Right. Let's see.
And if something dangerous happens, it just rolls it all back and you get an alert in Prometheus or something.
Yeah, let's see.
I'm excited. This is a very cool demo.
Okay, enable Canary. So I'm going to configure my app for Canary deployments going forward. I'm going to, again, tell Flux, hey, synchronize all my changes. And now Flux should create the Canary custom resource. And if I'm going to look in the apps namespace, and I'm going to do get canaries, I should see that, hey, Flagger is doing something. It has seen the pod info canary and is starting to initialize the canary. Let's see what initializing the canary means. So if we look into apps and we look at, for example, deployments, we see that the pod info deployment is no longer running. It has been scaled to 0. There is nothing running here. And I'm having a different deployment, which has a suffix called -primary. And this one has 2 replicas. Let's look at horizontal pod autoscalers and see what happened there. Same stuff. There is a different horizontal pod autoscaler, which is not managed by Flux. This one has been generated by Flagger. So what Flagger does, it takes what the desired state from Git, what Flux applies on the cluster, and it creates a clone of that, an immutable clone on the cluster. So you cannot change these things directly through Git. You can only change this one and this one. And these are the things that are actually running. If we go back to the app, let's see if Flagger has also set up the gateway API and all the things, right? So I'm seeing here that the pod pods that are serving this are no longer pod info, are pod info minus primary, because Flagger has set up networking, the gateway API, in such a way that all the traffic goes to this clone, to these primary replicas. It has a primary horizontal pod autoscaler. And let's say if your deployment, you have referenced secrets, config maps, and so on, Flagger will also create clones of those. No matter what it discovers all the dependencies of your deployment and it clones them all and creates this primary copy that you no longer control at all from Git. It's only Flagger that controls it. Now, if I want to change something, going back here to my application, and let's say here I want to deploy 601. Let's push this change, deploy 601. Going to tail Flagger logs here, and right now we said
you're pushing that from
initialization
code bases as well. That's so cool.
Okay, so Flagger told me I've initialized the Canary, I've scaled down the deployment, and now primary is running everywhere. But I've made a change to my deployment in Git, right? And what Flagger says here, oh, a new revision has been detected. What happened is that Flux saw the change that I've just committed, applied it on the cluster, but instead of rolling the change directly to end users, it rolled the change to a deployment which is scaled to 0. So nothing actually changed for your end users. If we go back to the app, we see that, cool, we are still on 601, nothing changed. What Flagger is doing, he says, okay, a new revision has been detected. Let me roll it out. It waits for the horizontal pod autoscaler to set the mean replicas, which are 2. It has run the smoke test. And now it starts to update the HTTP proxy custom resource and increases the traffic weight to the new version. Now it has increased the traffic weight, then it went to Prometheus to read what that increase resulted. Are there any error rates and so on? And Prometheus does not yet have all the data. So Flagger retries at some point, because Prometheus scraping is set to 15 seconds. It takes some time until it gets all the metrics. And now it has the right metrics, so metrics are reported. And Flagger advances with the traffic shifting towards the new version. So if we go back here, if we are lucky from all this, there is also load test running on the background. So it could take some time until my browser ends up on the new version. But let's see. 601. Okay, now I'm getting some requests to the new version. Now I'm getting all the requests to the new version. Goes back. Because, well, it's load balancing based on a request. So each request is routed to a different version depending on how lucky you are, right? So it's still, some requests are going to the new version, some to the old version, because the maximum weight between the two versions are set to 50%. So everything went fine. It has reached 50% traffic. And now what Flagger is doing is copying, again, is doing the copy from what Flux applied to the deployment that it controls, to the primary one. So now it copies everything, it promotes everything from what you're describing it inside the cluster to the primary, and it scales back to 0 the deployment that's in Git, and now everything is routed to the new version. So if I'm going here, I should only see 601, and 600 is gone from my cluster. It's no longer there. A new version has been rolled out. Now, you may think, what happens in a continuous delivery pipeline? Like, how can I make this go automatically? When I publish a new version, I want some automated thing to start the Canary. I don't want to go in here and bump the version every time. Right. There are many ways of doing this with Flux. One option is here. You can change it to a same word and you can give it a range and so on. And another option is to use Flux automated image updates. So, and we are going to use this option. So here are some custom resources where I'm telling Flux, hey, the container repository, where is my app being pushed on the registry? So I'm telling Flux, go here, fetch all the tags of this repository. Then I'm defining an image policy where here I have a sample range and I'm telling Flux, if you find a newer version of 6.0 whatever, so if there is a new patch version available in the container registry, then write back to Git that new version. And this is how you can tell Flux to write back to Git and modify YAMLs for you with an image update automation, where you tell Flux, use this Git repo, check out this branch, use this data to do the commit, and push back to the same branch. Now, this is fully automated. A new version is being pushed to the container registry. Flux discovers it. It writes back to the same branch, to the main branch, where it also synchronizes all things, and it will patch the version there, right? And I'm telling Flux where to search for these markers. Okay, let me put this here so you can actually see what's going on. Okay, I'll automate podding. So what I want Flux to do is using this marker, which is a YAML command. I'm telling Flux, hey, apply this policy to this YAML node and replace the value of the YAML node with whatever you determine is the latest tag. So what Flux will do, instead of modifying the cluster state directly, like you would do with the kubectl set image, instead of doing that, because that is not GitOps, you have to have your desired state saved in Git. You tell Flux, every time you discover a new image, write back to Git that change. And the other part of Flux source control will pull that change and will apply it. Then Flagger will start a progressive delivery with an analysis for the new version.
So this is important because your image automation is actually going to commit the desired state back to Git, right? This is a pretty special thing to do. And when you commit it back to Git, then say if I want a new cluster that has the same makeup of everything, right? Like we don't have to run the policies inside the cluster immediately. Like as soon as everything bootstraps into the cluster, it's going to be the right version, right? Or like if I respond to a disaster and have to recreate my production environment, like you can. You know that like back when you set up that automation, when it was like version 3, you know, or version 6.01, and now you're version 6.20, like you're not going to accidentally deploy the old version for 2 minutes before the controller wakes up and notices something is wrong, right?
Yeah.
Interesting. That's a very important edge case when you're talking about disaster.
Yeah, so I have Flux has applied those image policies and update configurations, and this is what it's currently running on the cluster. So is this image repository, and Flux said, hey, I have successfully scanned its container registries. I found 25 tags. Then the image policy said, from all these tags, I have determined that for podinfo, the latest version according to the Sandberg filter is 604. right? And this one, I didn't code it fast enough. This one already has committed the change to Git and said, hey, last commit that I did was at this with 604. Now, if I go back to Git here, and I'm going to do a Git pull, I see that there is a new tag, 604. If I look at who actually committed this change, 3 minutes ago, it was the Flux bot, because that's how I configured the commit username to be. And this is what it has done for me in Git. So now I have a trace in the Git history. Okay, I have released a new version of my app. Flux has detected it. It wrote the new version in Git, but this version is not exposed. Oh yes, it is, because it has already finished. Yeah, Flagger has routing all traffic to primary. It was way too fast. I should have increased the traffic weight a bit. Promotion completed. Yeah, so while I was talking, Flux has committed the change. Flagger has seen the change, has run the analysis, routed traffic, then it has pushed the new version. And yeah, that was demo. I can also show you a rollback. We can simulate 500 errors, and we can see how the rollback goes. Do we want to do that?
Yeah, that would be awesome. Sorry, I got in the way of your very tightly timed Canary. The robots were too fast.
Yeah, let me.
Also, a question for you afterwards.
Okay, let me get a command that will generate a bunch of errors. Gonna start a load test from this machine that will generate 500 errors.
So Flagger is still watching the Canary to make sure it's okay.
Yes.
And you're gonna make it not okay.
So the promotion is done now. Now I'm starting the load test that takes 10 minutes, and it should give me enough time to spin up a new version. So what I'm going to do now, let's say I want to roll back to 603. If I change it here, it will not have much of an effect, because Flux will say, hey, but the latest is 604 and so on. So instead of changing it here, I'm going to change it directly in the policy. So I'm going here at the policy, and instead of this range, I'm going to say, hey, deploy this exact version.
You're pinning
this is how you could do a manual rollback, for example, of Flux image automation.
Because the image policy is the robot that controls what version should be in your repo now. So you're like pinning it, and it's going to go and update it for you now.
Okay, I'm going to sync this. Okay, everything is synced. Now, if I do Flux, get Flux in the apps, namespace get images, get me all the custom resources. Flux has resolved an image 603, and it has already pushed the change. Let's see if that actually happened. We can do a git pull. Okay, now it's 603. Let's go to Flagger now and see what's happening.
And you're probably waiting for that customization to reconcile because of the new change, right?
Yes. So there are basically two reconciliations here. One is from outside the cluster, you see a change in a container registry, you make a change in a Git repo, then the other part of Flux is, oh, there is a change in the Git repo, that let me apply it on the cluster. Then Flagger says, oh, there is a new revision, let me do the Canary analysis for it. And now it has started the Canary analysis for 603. And because we are now pushing a lot of errors everywhere, it should also hit the Canary instance, and the Canary instance should run into errors, and the threshold is very, very low. My toleration is 1% of all things should error out. Now everything errors out, right? So
Very
what
cool.
Flagger is saying, hey, halt, I'm not going to give the new version any more traffic weight. I'm not going to increase the traffic weight. Let me see if it recovers. Let me see if the error rate maybe goes under 1%. It will not happen even if Flagger now has started a load test. It will go around 50%, but that is way, way higher for the threshold that I've set, right? And I've configured Flagger in the custom resource in the Canary. Hey, even if the SLAs are failing, check them 5 times, like do 5 iterations, read the metrics again. Maybe there is a problem with the application at startup. Maybe I'm having, I don't know, a Java app that has all sorts of issues at startup. It needs to load a bunch of stuff, so it cannot respond correctly. But maybe later on it will recover, right? So Flagger gives you this opportunity to, not set things in stone and have all sorts of tolerations for these metrics checks. So it has tried, failed 5 times, and is saying, hey, rolling back pod info, failed checks threshold reach 5. It has rolled back all the weights. Now all the traffic is back to the old version 604, and it has scaled down the app.
Mm-hmm.
Now we are in a odd situation, because if I'm looking here in apps, get deployments, I'm looking at pod info. Sorry. Right, the version here is 603, with matches what's in my Git repo. But this version has failed. It has a bug, it has some issues, and so on. So it wasn't promoted. If I'm looking at podinfo minus primary here,
This is the copied deployment, right?
yeah,
It's like the real one that Flagger is managing.
this one is on 604. Why?
So
Because the desired state wasn't good. I said, hey, I want to deploy 03. That one has an issue, and Flagger didn't promote that. So here, this kind of situation has to be treated as a production incident. Flagger will sends notifications. Flux sends notifications. You also have Prometheus metrics. Also, Flagger and Flux are instrumented with Prometheus. So the moment this Canary failed, you if you configured alert manager, or you look at your Grafana dashboards, or you configured alerting in Flagger, Flagger will tell you, hey, the new version has failed. So now you have to take a decision. What are you going to do? Are you going to modify the image policy to get back to this version, which is actually working, or maybe fix something in your source code, publish 605, and then enable Flux to bump that version automatically, right?
yeah, if you're using the image automations, all you have to do is push a new version, right? Or
Yeah.
it's one of the things you can do. And you don't have to touch the Git repo. You don't have to touch Flagger. You don't have to log into your Kubernetes cluster. You can just get the alert, work with the dev team to fix the code, and then Flagger will see the new revision, right? And it'll go and it'll enact your policy again, right?
Yep.
So Very cool stuff. And you're not using a service mesh here, right? Because Christian, he wants to know what kind of service mesh does Flagger support. I understood that this was a requirement, but you're not using one, right?
No, I'm using an ingress controller. So Flagger has support for
Maybe zoom in there too. Mm-hmm. Yeah, there you go. Mm-hmm.
So these are service meshes that Flagger supports: Istio, Linkerd, Open Service Mesh, Kuma. And now, because it supports the Gateway API, there are other service meshes that work with that. So Flagger will also have support for it, like Consul, Service Mesh, and others. That's the beauty of implementing an API that has been adopted by more than one technology. It's like Flagger has benefits a lot from that. We don't have to go in there and work with Kuma service mesh custom resources and code all that logic, doing changes over that. If we Now that we have the gateway API support and we also have the service mesh interface support, I expect future service meshes and future ingress controllers to choose one or another. So we
Yeah.
don't have to change Flagger moving forward. They will just work by default. And here are the ingress controllers that work with Flagger. So it has started as a tool that only worked with service meshes, and that was because there were no rich APIs and rich capabilities in ingress controllers. But that completely changed. I mean, Contour grew, including the Nginx ingress controller that Kubernetes team manages it. Also, that one, which is the Nginx open source, works as well, and it can route traffic, it can do A/B testing, and so on.
Yeah, pretty wide support in the ecosystem for a single tool with a single Canary definition to enact policy on version and routing changes in all of these different interfaces. And for the most part, like you could be, running a Linkerd, in a EKS cluster, and then you could have traffic on your home lab, and then you could also have traffic running on the, or Nginx ingress, and you could use canaries with all of that as long as the Flagger installation was configured properly, right?
Yeah.
Yeah.
And yeah, I hope in the future the CNCF ecosystem will consolidate around these two generic APIs, so we don't have to keep integrating with yet another implementation. So
Yeah, with the gateway API basically and
SMI, yes.
SMI. Yeah, that makes a
Linkerd,
lot.
for example, works with SMI. Istio now is replacing their custom API with the gateway API. Console has adopted the gateway API, and all the ingress controllers, I expect very soon they will move from ingress v1 to gateway API. So things like Apache and all the others will just work by default with Flagger. There is one thing you have to do, and one thing that these APIs do not solve, and is the part of the metrics and analysis. That's where, in order to make the progressive delivery valuable, besides error rate and latency, which every single proxy can show you, to make that valuable, you should also add custom things, like maybe look at how many database connection did my new version open. Oh, maybe there are too many. Maybe to block everything, right? So,
or even if you were doing A/B testing, you can do like more business focused custom metrics like conversion rate or click-through rate or something.
Exactly.
Yeah.
But for that, you have to change your app, right? You have
cache
to
depth, custom app stuff, about usually metrics about like your data structures or your queues or something, different data stores you have. Yeah, it's like at the end of the day, if you're trying to do these kind of like googly SRE practices and do progressive delivery like Netflix, some of the tooling will get you there, but it's also how you work with your team and like how you mature your engineering practices that allow you to do the fun stuff, right? There's another great question from Christian, and he just wants to know, how does Flagger work together with Helm releases? If you're using the Helm repository as the Flux source, then like how can you make Helm and progressive delivery work together?
So you'd tell Flux to update the Helm release to a new chart version, and you can place the Canary definition next to the Helm release, right? And the Canary definition will target the deployment that's bundled inside the Helm chart, and it should work the same as with Flux Customize. I mean, there are many Flagger users which are using only Helm. The first tool that adopted Flagger was Jenkins X before Flux worked with it and so on, right? And Jenkins X is all about Helm charts, and they have Flagger built in and so on, and they chose to embed the Canary custom resource inside the chart. For Flux, I would say place the Canary resource next to your Helm release, and when Flux applies the Helm release, it also applies the Canary. The nice thing about Helm is that the Flagger tester can run Helm tests. So when you, instead of running it with Flux, you'll tell Flux, hey, upgrade my Helm release. Then Flagger will detect that change, and then you can tell Flagger, run Helm test for the Canary, and before you route any kind of traffic. If Helm test fails, then roll it back, right? So
yeah, kind of in the same topic as well is like, how can you make Flagger work with Helm? Is how do image update automations work with Helm? Could you attack that a little bit?
It's all about versioning. So you can, if let's say your Helm chart follows the same release scheme and version as your app, you can use the image update automation to change the chart version. If you version your chart differently from your app, then inside the Helm release, we also allow customized patches. So you can say, do not patch the chart version, patch the container image tag from inside the chart. So your chart will know whatever is in the chart in ValuesYAM or whatever no longer dictate what app version are you running. Is the image automation which dictates that. And that has a lot of disadvantages when you jump from a major version to another, because usually when you release a new major version, you'll probably have breaking changes that require new configuration. So if you just change the image tag, the chart is old, it will contain some config map, some container args, the container is new, and everything will break. And Flagger will help you,
reduce the
not
blast
expose
radius.
that to end user. It will stop it before you get to a failed deployment. But we are looking at ways to expand the image automation workflow
to other sources, basically. Like,
yes,
this is basically like a tag list from a image repository, right? Now you want to look at other tag lists and maybe do other kinds of update automations.
Yeah, for Helm is kind of sorted because Helm now has officially support for OCI. OCI is in development in Flux. So once you have a Helm chart that points to an OCI repository where that's the chart, not the container image, you can use image automation controller to bump the chart version, right? And that will work fine. So we can reuse the image automation controller because it looks at OCI and tags for all these things. It gets tricky when you use the old way of publishing Helm, which is with Helm releases and index YAML and so on. And there you have this issue with mismatch between versions.
Yeah, you're getting some love in the chat. Java Grunt said, "Thanks so much for the session. He'll be rewatching it." Alexander Smirnov wanted to know if there's any possibility to visualize the analysis results in some sort of report, say from like the Flagger Canaries.
Flagger comes with Grafana dashboards where there is a split view, primary and Canary, and you can see all the graphs in parallel for the metrics that Flagger knows about, like error rate and latency. But I think that kind of view, that kind of Grafana dashboard should be improved with all the other custom metrics that you'll be using. But you have something to start off and build your own dashboards for Canary releases.
Very nice. Yeah. Well, Matt Wilson says this was super educational. I guess Matt is responding to wanting to watch this later as well. I definitely think that those out of the box metrics dashboards as well. Some of the ingress controllers and service meshes all have some interesting dashboards for the generic sort of reporting, but you're not going to get away from having to build your own visualizations with your own metrics. But if you want that state about the Canary being successful, I guess that stuff is pretty much out of the box, right?
Yes, in the Grafana dashboards. That comes with Flagger.
Awesome. Yeah, more praise coming at you from the chat here. Just very nice demo. Enjoyed watching. Thanks for everyone for coming. If you've got any last minute questions, it's time to squeeze it in. But Stefan has been demoing for well over 2 hours here. You know? What time is it for you now? It must be 10 o'clock, yeah?
No, it's 11.
11 o'clock. Yeah.
I have to go eat.
Romania. It's time to eat some food. You know? But yeah, it's that wraps up a pretty fire. It's episode 89 of Tanzu Tuesdays. As always, thanks to the chat for coming in, interacting, providing such good content. And we'll be back here next week for I don't actually know what because I'm disorganized, but I think all of y'all feel that today, right? So yeah, we'll be rolling out with our outro here, and you know. Thanks, Stefan, so much for coming and imparting your wisdom on progressive delivery, scalable GitOps here. You know, go check out the Flux project, clone the repo. It's up there on GitHub, you know, and mess around.
Bye.